Yeah, welcome to my presentation about cloud and trust and security. But before I come to the actual topic, let me shortly introduce myself. I have a passion for Sicherheit. I talk a little bit German. Sicherheit is a German word and means both safety and security. So the security part is my job. I'm teaching and doing research in the field of IT security for about 10 years now. And that's why I'm also here, of course. And the safety thing comes with my private hobby. You can see it here. You can see me here, some of these pictures. Safety comes with mountain climbing, and I think you can imagine when you hang in a wall and you have 200 meters just air below you, then safety and safety equipment and trust in your partner is an important thing. Yeah. The talk is structured in the following way. First, I give a short motivation why security matters in the cloud area and why it's very important at the moment. Then I come to the specific to the concrete problem that we want to deal with, which is the insider attacks. And then I come to the technologies which our system are based upon. These technologies are, on the one side, it's mandatory access control, and on the other side, it's different trusted computing technologies, which are integrity measurement. We have already heard today, before lunch, a little bit about it, and talk about hypervisor attacks. Very often this term is, secure boot is used for this term instead of integrity measurement, so you know maybe secure boot or trusted boot. The other technology is attestation, remote or local attestation. Then I come to the architecture of the software that we use for our system, and the ecosystem. Ecosystem is more the non-technological part, that is the organizational environment. Then I give a short overview of related work. There are many scientific and practical work going on in this field. And last but not least, to the conclusion. So for the start, if we have a high-level overview of cloud scenario, we typically have two entities. We have the cloud customer and the cloud service provider. Both, of course, have valid security goals. In this talk, in our work, we focus on the customer's security goals, which are confidentiality and integrity of the customer's data and the customer's virtual machines. For the motivation, it was not difficult to prepare the slide because there are many surveys and studies around which show all more or less the same. Security is the top inhibitor for companies and organizations moving or not moving to the cloud. You can see it in the red curve. The numbers here are not important. This survey shows the same. So security is always a top concern. Then there are many other headlines, and there was a talk at the RSA conference this year, and so on and so on. The other thing which is important in this talk is the insider attack, the potentially malicious insider. If you look at this document here, the Notorious 9 from the Cloud Security Alliance, then you find the insider attack stated as the 6 important attack. I found some real-world examples of insider attacks or of attacks where rogue bad administrators did bad things. There is this one from 2012, which you can find at search.org, where a rogue administrator had access to a file with encrypted information, and he was able to brute force the information and do bad things with this. And the other example, it's quite an old one, is from 2007, but I think it's the more famous one because it was quite a large-scale leak of confidential data at Salesforce.com, where an insider or an employee of Salesforce revealed customer information, not passwords, but just customer data, to a phisher, and the phisher itself used this data for, in the follow, could do an attack. And there was also the keynote today in the morning, the keynote by Alexander Hutton, where I wanted to ask him to get his slide. There was I think it was a third slide or something, where he had the classification of different attacks, and the insider attacks were 18% of all attacks. So this keynote showed the same: insider attacks are important. Well, if I extend the simple picture from before, still very simple, then now we have the insider, who is typically a privileged user or the cloud administrator. Of course, the cloud administrator must be able to control the host on the cloud provider side, but on the other side, the cloud administrator should not be able to access the guest image, and that's the problem, because the host, as we all know, runs privileged code and typically has access to the virtual image running on top of the host. But that's exactly what we want to confine, to restrict the cloud to the administrator from access. So the prominent statement of our work is how to assure that a possibly malicious insider at the provider's side has no access to the customer's virtual machine. The assumptions we have used in our work is that the insider has no physical access to the host machine, and that the cloud provider itself, the organization itself, is, let's say, partly trusted. That means, with partly trusted, I mean that the provider himself is not malicious, but on the other side, he could be careful. So he could do an error by accident. A very simple solution, typically if you think about confidentiality and security, we say throw in some crypto solution and it's fine. And that's the first idea that comes to mind. Just encrypt the virtual machine, send it to the cloud provider, and everything is fine. The problem, of course, is we have a virtual image, and the virtual image must be executed on the cloud provider side. So I think that's clear. It's not possible here because it must be decrypted on the provider side. And then where is the decryption key? And finally, the provider and the administrator has access to the virtual machine, which possibly has sensitive data on it. So encryption is only an option if we have storage clouds, but not if we have clouds where we execute machines. So to come to the solution that I want to present here, the base of this is trust. There, I come back to my mountain sports. Again, here we have to trust on something. And the trust, we will see later, is based on trusted computing technology. I looked in the Merriam-Webster dictionary, and the definition for trust, it said, assured reliance on the character, ability, strengths, or someone or something. The important thing is here the assurance. So we need, or we want, in this case, the customer wants some assurance or some proof. With proof, I don't mean a formal proof, but some kind of proof that everything is fine on the cloud provider side. So how can the cloud customer get this proof now? Get this proof that everything's fine. That means that the provider's system, the provider's infrastructure is secure, or in other words, it's protected, that the cloud provider protects the sensitive information, the virtual machine, and that the cloud infrastructure is secure. I said already that he has taken controls against any threats, or as I said, in our work, against insider threats. Typically, such proofs or assurance in cloud scenarios are given by service level agreements, but very often these service level agreements do not fully cover the security dimension. They write about availability, about quality of service, but the security dimension often is neglected. And that means if any proof exists at all, this proof is done by an external audit organization, by a certification that is given to the cloud provider. And here I want to show another way to increase the assurance about the trust provider's infrastructure. The solution is based on these two technologies. I already mentioned this in the overview. It's based on MEC, mandatory access control, and these two TC technologies, integrity measurement and attestation, which I want to introduce right now. Mandatory access control is an access control model, and if you compare this to discretionary access control, one of the differences is that in DAC, the owner of a resource has full access to the resource. That means he can read, write, and he can give himself, if he's owner, he can give himself the rights to do whatever he wants. Mandatory access control, on the other side, enforces system-wide policies, so the owner of a resource is not able to change any access control. And the other difference between discretionary and mandatory access control is that mandatory access control is more fine-grained. There is not only read, write, execute, there are different access control possibilities, and it's not only based on file, but you can also pose access control confinements on, for example, sockets and other things. So in general, MEC is considered more secure than discretionary access control. I just give some examples that show the strengths of SE-Linux. Of course, this is not a formal proof or something, but it shows how the strengths of SE-Linux. There are different examples on the website or on the blog of Dan Walsh, who is SE-Linux guru working at Red Hat. He writes that SE-Linux would have been able to, or is able to defeat shell shock. That means if its system is not patched according to shell shock vulnerability, anyway, the attacker would not be able to exploit the attack. And the other example I show here, which is closer to this work here, it has to do with virtual machines. It's this CVE number 2011 and so on, where it was possible, or it was shown that it's possible to either crash a virtual machine or even to break out of a virtual machine. And again here, SE-Linux, that's what Dan Walsh is showing in his blog. SE-Linux could defeat this vulnerability. There are there were some nice examples of public available machines real systems that restricted the root user using SC Linux. They are not online anymore, but when they were online, they were the root password, root account, and password was publicly available, and as far as I know, nobody was able to break out of the SC Linux restrictions. In our prototype, we used SC Linux to restrict, or we tried to restrict root from accessing virtual images. That's the main point, as I said before. From the cloud provider administrator shouldn't be able to access virtual machines and other things. Here is just a snippet from our output of ls-z. A little bit of output is omitted here, but it's a Linux security context or it's a Linux label you can see here, and this is the virtual image file. The other thing we do in our prototype, we create tamper-resistant log files. That means even root is not able to manipulate or change the log file, so everything he's doing, if he's copying virtual image file or whatever, is logged, and this log file can definitely not be manipulated. A problem with SC Linux, of course, is that the policy file can become complex. Our policy file is not yet complex. It's work in progress. It's definitely not finished, not production ready, and especially with these points from above. I would be careful with this. This I'm quite sure about, that SC Linux can do the point from below. That means creating tamper-resistant log files. On the other side, beside the technical things with mandatory access control, of course, there is a conceptual problem. The provider wants and needs an administrator who is able to do, for example, updates, and via kernel updates, for example, the administrator could bypass the SC Linux rules. This is more a proposal for an organizational thing. The typical principle of least privilege should be adhered here. We should have, that's a possibility to have two root user, a default root user with the normal root user, the full power root user, but here strong authentication is required, only physically log in for as principle, maybe even applying a hardware token together with a normal password. There is a paper on this, and we'll think about incorporating this hardware token thing into the authentication. And on the other thing, on the other side, there is the confined root user. That is the root user, not a real root user. It's more a privileged user for day-to-day operations. And then there are these, I don't go through all these, there are the usual recommendations for privileged identity management. As I said, I don't go through all this. You can read it in the different standards. But they, for example, say that logging is very important for privileged account, and that's why, as I said before, right here, we are able to restrict root from manipulating the audit file. This was mandatory access control, and the second technology which we base our system upon is trusted computing. And when talking about trusted computing, I think I start with the trusted platform. I start with explaining the trusted platform module. The trust platform module is a microcontroller, a slow, rather simple microcontroller. And the important thing is that the keys are quite protected. We can discuss this later on. They are protected against external attack and theft. And this TPM module is tamper resistant. That means it's not possible to manipulate and change it. It's quite cheap. Currently, I think it's definitely more. This number is from last year. So it's maybe 700 million TPMs sold already. There is the Trusted Computing Group, the TCG, which gave out the specification. Currently, the 1.2 specification is the current one, but the version 2 is just coming next. An important concept with trusted computing is the so-called root of trust. A root of trust gives the initial anchor for a security system, and the TPM can play different roles of root of trust. It can be the root of trust for measurement, which we used in our work. It can be root of trust for attestation, which we also used, and then root of trust for storage, which is not so important in our case. This is a simple figure of the components of a TPM. The gray ones are not important here. It's typically microcontroller components. But then we have a random number engine. We have a hash engine, which is also important later on. So we can put in data, and the TPM generates hashes. And then we have an asymmetric encryption engine. And very important here is the so-called PCR, platform configuration registers. Typically, it's 24 registers in a TPM, and they store hash values. And the point is, it's not possible to change these values after you have stored the value inside. When the platform boots, the PCR values are zeroed. But during a running system, you cannot manipulate it. You can just extend it. I come to the extend operation soon. The functions of the TPM we used in our work is the identification of the platform itself. There is a so-called endorsement key, which is embedded in the TPM. And for privacy purposes, there is a derived key from the endorsement key, which is this attestation identity key, AIK. And with this key, the platform, a remote entity can get information about the identity of a platform. As I said already, very important for our work is the storage for the hash values, these PCR values, and then the integrity measurement, which measures the system. Next slide will explain this in detail, and the attestation. Measured boot or secure boot or trusted boot, there are small difference, which is not important here, just for the concept of it. It's a technology to measure each software part of the system before it is executed. That means somewhere we have to start. That's the so-called CRTM, core root of trust for measurement, which is part of the BIOS, which is also a problem, I know, Xeno, which is part of the BIOS and which measures itself. It's the line number 1. The measurement value is stored into the TPM. After it has been measured, the rest of the BIOS itself can execute. Then the BIOS measures the bootloader. Measure means always creating a hash and putting this hash into the TPM. So the bootloader is measured, and the hash value is stored into the TPM. And then the bootloader can be executed, and so on and so on. I think I don't have to continue all the way up. The important thing is, I repeat myself, before each component is able to execute, it is measured, and the measurement value is stored into the TPM. As I said already, some comments on this, some remarks. First thing is, I simplified here a little bit. There is option ROMs and things like that. And the other thing is Xeno Kova, who is in the audience and speaker tomorrow, last year at Black Hat, I think, showed a way to manipulate at the very beginning, that is at this when the CRTM measures, they were able to show to manipulate it and still to lie to someone who wants to get the values. So of course, if the system is compromised from the very beginning, we have a problem. But they also showed a solution to the problem, time-based attack, not attack, time-based attestation, sorry, and chronomancy, I think. We have not yet incorporated this in our system. It's just about the principle. Yeah. Back to the concepts. After these measurement values are stored into the different PCRs, typically the boot process uses just 7 of the 24 PCR values. The other PCR values are then used for so-called dynamic measurement, which we don't do here. After these measurement values are stored into the PCR, of course, a remote entity wants to obtain these values in a secure way, of course, and this process is called reporting or attestation. Attestation of the platform means now that the remote party gets these reference values. And these gets these hash values. And these hash values coming from the TPM itself, of course, must be compared to some reference values which we provide. We must know we must know golden or correct values in advance, which we compare the PCR values with. This is the reporting and the attestation process. I don't go into all the details. Typically, I run out of time otherwise. But the important thing is here, of course, we use some nonce for freshness. And the other thing here is we use a signature key for, not we, the TPM signs inside TPM, the PCR values are signed. So it's done inside the TPM, and this leads to this property that it's not possible to manipulate the value, which we want here. This is our prototype. Our prototype system, our architecture of our prototype is based on these technologies. We started 3 or 4 years ago with our work, and that's why some of these technologies are out of date. But anyway, our prototype is based on Trusted Grub, the bootloader. This is an extension of the Grub bootloader, which includes this measurement things to measurement process together with IMA. So these two parts are responsible for the measurement. IMA stands for Integrated Measurement Architecture. This is a open source software from IBM. Then we need all the TPM software, which is the driver itself, and the trousers, which is the API, the library for accessing TPM. Yeah, of course, SC Linux integrated into the Linux kernel. By the way, we used CentOS. I don't have the version in my mind. CentOS as Linux, and for the virtualization part, we used KVM. TPM tools are just some command line tools to do TPM related things. And the remote attestation tool is a simple software that we have written by ourselves to do this one, to do the attestation, the remote attestation. But at the moment we are working on a second version on this of this system, and we will definitely change trusted graph because it's not supported anymore, this software. As I said, it's quite old. So we will use T-boot, and we will use open attestation instead of our remote attestation tool. So if somebody wants to code, no problem, but I don't think it's useful because open attestation definitely better. It's open source, open attestation. It's from Intel to do the attestation part. This was the technical architecture. Oops. And now I want to show a little bit the overall ecosystem, how I call it, which is very important. So if we really want to put this into production, as I said, it's not a production software, but if we think about using this in practice, we need some ecosystem. That is, first and foremost, we need a trusted third party, which we in this figure, I call it a trusted third tester here, which has an important task here. It has this organization has to test and review and check the operating system, the mandatory access control policy file, and so on, which were built by open source community or whoever. It could be that this organization is the same. So in my opinion, the open source community would fit very well together with some specific organization in this to fulfill this role. And this TTT, Trusted Third Tester, then after having tested the hypervisor and the policy, creates hashes of a good whitelist system, creates hashes of these, and typically these hashes then are called golden values, and these golden values are signed by the trusted third party. We could integrate this trusted third party also in a typical certificate hierarchy additionally, so they could sign this with their certificate, for example. And these golden values, of course, are then used for the attestation part. This CAA is the software running at the cloud customer side, who does the challenge response process. That is the communication with the TPM, which of course runs on the cloud provider side, and this software also does then the comparison with the reference values, and if they are the same, it's fine, it's good, and we say, okay, we have exactly this system, that's good, we trust this. If not, yeah, we can do, yeah, typically we don't trust it. As I said in the overview, I want to show a little bit some related work, and I said already there are quite some work going on in this area. As I said, when I started 3-4 years ago to work in this area, there was just a little bit scientific publications on it. The last year, on the other side, there are, I wouldn't call it production system, but it's companies, big companies working on this topic. For example, Intel are working, let's say, massively on this topic. They call their software Mount Wilson and Mystery Hill. And on the other side, a very currently published work is Haven, and SGS is not so new, but Haven was published in, I think, August, September this year. I will just give some words on this work, and of course the many scientific projects and work going on. And I will go a little bit into homomorphic encryption, even though if homomorphic encryption, of course, it's another technology, but it has finally, it could be used for the same goal. That's the point why I also have it here. So for the Intel work, we have a Mystery Hill and Mount Wilson. I don't explain all the details, but actually, more or less, it's the same that we do. It's a little bit more elaborated. There is even a nice book on it. So if you're interested in this topic, yeah, this is the link for the book. You should definitely read the book. But as I said, they do the same. They have a whitelist of known systems, and they have a TPM, which measures the system on the host side, and then they do the TPM code, which is the attestation process, and then they compare the TPM PCR values with the whitelist. They also have a list of registered hosts, as I said already, with the AI key, attestation identity key, we can identify a system. And this, at the end, is sent to the cloud customer with a green, yes, it's fine, it's a system that we expected, or it's something else. Here it goes even more into details. Yeah, they extend this system with a software they call Mystery Hill. Mount Wilson is the attestation part, and Mystery Hill is a component that mainly it encrypts the virtual machine and decrypts the virtual machine on the provider side. Yeah, but of course it decrypts it on a system that has been attested in advance. That's the point. Yeah, but I think I have to go on. And as I said, this is not our work. It's the Intel solution. The other thing which I think is quite interesting and it has the same goal is Haven and SGX. SGX is hardware. It stands for software guard extension. Yes, software guard extension from Intel. And Haven is a software solution from Microsoft. Here's the paper from September 2014 or something. And just to explain it in 2 sentences, they want to build a inverted sandbox. I like this term. They call it enclave. And inverted sandbox, I think that makes it quite clear. If you have a normal sandbox or Java sandbox, you don't want the code from the sandbox goes out and can access the environment. With the inverted sandbox, it's the opposite. You don't want that the environment has access to the sandbox itself. Even so, and that's the problem, even so that the environment is the privileged code, is the host code. That's the point. So finally, the goal is the same that we want to reach. But the technology they use is a totally different one. Yeah, and the third technology that I want to bring in here is homomorphic encryption. I think most of you know the idea. For those who don't know it, very simple explanation of homomorphic encryption. The idea is that you can perform operations on ciphertext. In the figure here, you see two hexadecimal numbers, and we encrypt them, and then we do some operation on these numbers. For example, here adding them, and this is the encrypted output. The point is this is encrypted. This is cipher result, so nobody can read it, and only the person, the organization with the decryption key can decrypt and gets the plain text result, which is in this case, in this simple example, it's just adding these 2 hex numbers. But the point with homomorphic encryption is if it's efficient enough, then we could say we have a crypto computer. We can finally, if we can do any operation that a processor can do, then we have a crypto computer, meaning we can execute encrypted code. And then, of course, we don't need the solution I propose here. If homomorphic encryption is fast enough, efficient enough, but as far as I know, at the moment, it's not. But if we have it, then you can forget our system here. Yes. Back to our system, there are, of course, some problems with this TPM-based, this trusted computing-based solution. There is not as bad as with homomorphic encryption, but we also have an inefficiency problem. The point is measuring is a slow process. The TPM is a very slow microprocessor. It does its job. It's quite secure, but it's slow. If the trusted computing base, that is the software that we want to measure, is big, it takes quite some time and it's impractical. The typical solutions, if you read scientific papers, you find lots of papers that try to minimize this software, this trusted computing base, as it's called. And another possible solution is the dynamic root of trust, which does not start with the boot chain measurement, but it can be started. The measurement can be started with a specific hardware call. But I don't go into the detail with dynamic root of trust here. The other problem, of course, more organization problem, is the management of the golden values. I think in practical terms, that's a very big problem, because the systems come in many, many variants. We have all the different versions of operating systems. We have different configurations. Each company has different. If there is a single bit different, as we all know, the hash values will be completely different, and we cannot compare it anymore. So we must have a 100% identical system to compare the reference values. Same with the MAC policy, it must be totally identical. A solution could be to modularize the system and so that for each, then of course only and we change a module, then only the hash values of this module are changed and the rest will stay the same. So we have individual PCR values for individual modules. Another problem is all these attacks on the TPM, and I already mentioned Xeno. Oh, I think I wrote you wrong. I have to correct this. That's you. Tomorrow he's talking at DeepSec, and I already mentioned their attack on the CRTM. There is another attack from Tarnowski, which is on the hardware level. Tarnowski was able to kind of melt, I don't know the English word, to melt away layer by layer from the TPM, and this way getting to the private key and getting to the PCR and so on. And if we get the private key, we have a problem, because that's exactly what the TPM should refuse to do. It should refuse any access to the private key. So here, of course, the manufacturers it's important that the manufacturer of the TPM module works thoroughly and have all the diligence in the manufacturing process. And on the other side, as I said in our problem statement, if the insider has no physical access to the host, he cannot do Tarnowski attack, of course, because he has no access to the TPM and can do these things. Another problem is time of check, time of use, TOC2 attack. And we are currently working on this problem. We want to encrypt the virtual machine image, because at the moment we do the problem with TOC2 is, just in a simple sentence, if we do the attestation and then we launch the virtual machine or send the virtual machine to the provider, what has happened in the meantime? Maybe the provider has manipulated the system. But we have still the old attestation values. That's a problem with TOC2 for those of you who don't know it. But if we encrypt the virtual machine image and seal it, sealing is another special function of the TPM, which kind of binds encrypted data on the one side to a key. That's normal. We always bind to a key when we do encryption. But on the other side, it's also sealed or bound to the PCR values. So that means it's only possible to decrypt it when the PCR values are the same as those that what we give to the system. That's sealing. I'm already, I think I missed this. Another problem, which I think is also quite a big practical problem, is that most of the providers, I guess so, will not be willing to disclose details of their platform. Typically, and that's what we need for attestation. With attestation, the requester knows exactly what system, what version is running on the cloud provider side. So the question is, do the provider want this? There are solutions to this problem. The solutions are called property-based attestation. There are several papers on this topic. One of the papers are here. Yeah, to the conclusion, time is up, I just heard. Trusted computing and mandatory access control are very promising technologies to increase trust in cloud system, and I think they complement each other quite well. As I said in the problem section, there are a lot of organizational bases we need. We need this whitelist management. We need an entity that tests the system, and this entity also has to publish the golden values. Well, and our research outcome of our system is that we were able to build a prototype that makes it hard for an insider to access virtual machine, that makes it impossible to manipulate the logs, even impossible for a root user, for the administrator to manipulate the logs. And the cloud customer gets a proof that such a system is running on the provider side. And last year, the DeepSec was on the motto, failure vision, something. And my vision is that one day trust in cloud is similar to trust in a mountain guide. This is the symbol of a mountain guide. And with this, I would like to close and say thank you for your attention, but maybe also thank you for your attestation.
Hi. So you're using Secure Boot attestation to assure the customer that they're running the correct software on the cloud provider side. Then we only have to solve the quite easy problem of making sure that the software is free of bugs, right?
Yes.
So who solves that problem?
That's another problem, definitely. No, of course. We cannot solve this problem here, but of course we all know we need good people to write good code, secure code, not good code, secure code. And we haven't touched this problem here, not at all.
Okay, and then if say we have some kind of standard to hold this code to make sure that it's good enough to some level of security, then how does the cloud provider and the customer agree on that level of security? That's because these customers aren't going to be security experts, right? So is that where the bagfiller comes in and says that, well, we certify that this configuration is secure or something like that?
Yeah, that's exactly the task of this. So I said already that this TTT, or however we call him, He has a very important task. That's exactly what you say. He has the task.
And who do you envision
test it
fulfilling that role? That
and
was my
fulfilling
question.
this role. We need. That's why I say there's this technological side. We have more or less done this, and then this big problem of, no question, no doubt, big problem of organizational. Yeah, but the big difference is that we know what is running at the cloud customer side. At the moment, you don't know anything. Most of the cloud providers, they don't let you see anything. And with this system, you see it even live. You don't only have a service level agreement. Yeah. Yeah.
Two questions about homomorphic encryption. First question, what is the current status of homomorphic encryption? Where are we in the development of this technology? And second things, what do you think about the main cloud providers about implementing the homomorphic encryption? Because we know that a lot of cloud providers have for business model to sell the data we give them to work on.
Okay, there's two questions. The first one, homomorphic encryption, where are we there? Yeah. As far as I know, I'm not an expert in homomorphic encryption. What I've read, the biggest problem is the efficiency problem. At the moment, they can encrypt keys of 256 bits or something in a reasonable time, but not virtual image and not data. That's what I know. But maybe somebody in the audience here knows more about homomorphic encryption, where we are. Yeah. And there is this library. There is a library produced by some IBM people. You can download code for, there is even code for homomorphic encryption. But they state in their README, if you download it, they say that their software is for scientific purpose only at the moment. More or less something like that is in the README. So that's where we are, what I know. And the other question, what was it again? Yeah. In the paper that I've written for the DeepSec proceedings, I have a section on this. Because the question, I think that's the question. What has the provider with all these things? What is his advantage? At first, there is no advantage for the provider at all. He has a lot of technology to implement. He has to reveal it. The point is, what I can say, the provider has the advantage that he may gain some customers, because as far in the introduction slides, all of the customers, all of the surveys say, we want more security, we want more of this. So if some provider would provide a system that is, let's say, more trustworthy, well, I think he's more competitive. That's what I think for a provider. But at the moment, I don't know any provider who is using a system like that. All of these, even practical, in real-world system are prototypes. There's one with Intel. Was some systems. I think Singapore stock market. They did something with them. High Trust is the company behind. They do the same. Yeah.
Armin, my question is somewhat related to that one. What does this do in terms of costs? I mean, is this not for a specific group of people? Aren't most customers just interested in going to the most cheap cloud provider?
Yes. I think for such people, that this system, it's too expensive. This system is much more for critically sensitive data, sensitive virtual machine, or even a good, I would say a good application would be critical infrastructures. At the moment, if you talk with them, they say, well, it would be nice to go to the cloud with our data, but they don't do it because of this problem, because of security concerns.
Marks, in terms of cost, I mean, will it be double, triple the amount of money for, like, in comparison to an Amazon cloud system?
The point is, I mean, the hardware, as I said, it costs nothing. Nothing. For $1, $2, nothing. But the point, of course, is the software. That's the question. How much does it cost? And how much do we trust it? Again, it's always about this trust. Huh? If we don't trust this or Mount Wilson software, so what? So why should we use it? It's always about this trust. Trust is the main thing.
In my experience, actually, a lot of the people I've dealt with are not interested in the cheapest solution. And I wondered if there's any crossover with things like the US FIPS standards, and I expect that if they could be expanded to include this sort of standard, then that is precisely the sort of standard that many people would pay for, and to know that it's been ratified to an agreed standard by IE or whoever.
Mm-hmm. Mm-hmm. I also think, I also have written it in the proceedings paper. If we think about this, all these compliance things that are coming up more and more, and then if we combine it with the keynote from today, there he said measurements are important. I know he meant different measurements, not these. But anyway, we need some measurement, and especially in these compliance standards, regulations. We need some assurance, and this could give some assurance. Huh? I did not understand.
Next question. We've been talking now about the one application of the cloud is running virtual machines. The typical cloud providers also provide things like databases, tuple stores, backup services, load balancing, whatever, not just running virtual machines. Do you have any idea how you can protect those other services from the malicious insider? Not something that's running on your instance, but some cloud service your instance is using, like a database server, tuple store, backup system.
To be honest,
whatever.
we haven't thought about this topic.
Okay, so I have to agree with you that attesting to the customer that you're running a particular piece of or a particular configuration, that doesn't cost anything, right? Like you said, $1 for the TPM chip and some software. The cost is in the testing, right?
Yeah.
That's what costs.
Yeah.
So what is different?
Always different.
What does this buy the customer in terms of assurance when the cloud provider could provide a trusted third-party consulting firm or somebody else that both parties trust to do an audit of their systems and attest to the fact that they are secure, because that's what they need to do here anyway. What extra assurance is the customer buying with this attestation that they're actually running the software that's been audited? When the actual...
You mean what extra he's getting?
Yeah, because
Yeah.
the value for me is always going to be in the auditing of the software.
He's getting it live. He's getting an assurance that right now, on the cloud provider side, this tested system and so on, this good system is running. That's what he's getting with this system. And that's all.